In a world where we travel from Nashville to Nashville to learn about
We gon' find you. I'm letting you know.
momentum, impulse, and collision starting in 3, 2, action!
Momentum is a measurement of mass in motion. How much mass is in how much motion. It is usually given the symbol p. Momentum's equation is mass times velocity. Momentum's units of measure are newtons, seconds, and kilograms times meters per second. Change in momentum is mass times change in velocity.
An example would be if a car of 30 kilograms is going at a velocity of 20 meters per second squared, you would simply plug and chug those two numbers in the equation mass times velocity. So it would be 30 kilograms times 20 meters per second squared equals 60 newton seconds. Meg showed momentum when she was simply going down the slope because she would need the same amount or greater impulse to bring it to a complete stop. Newton's second law states that the acceleration of an object is directly proportional to the net force acting upon the object and inversely proportional to the mass of the object. When combined with the definition of acceleration, the following equalities result. Force equals mass times acceleration, or force equals mass times change in velocity divided by time. If both sides of the above equation are multiplied by the quantity t, a new equation results. Force times time equals mass times change in velocity, meaning impulse equals change in momentum. An easy example of impulse is a car traveling down the road is slowed down slightly when the brakes are just gently tapped. The force of the brakes is exerted over a small time, resulting in a small impulse and a small change in the momentum of the car. Now let's put it in an equation. What's the impulse when a force of 20 newtons is exerted on a car for 4 seconds? Got the answer? Simply plug and chug in the equation, and it becomes 20 newtons times 4 seconds equals 80 newton seconds. Skirt! A collision occurs when two or more objects hit each other. This force imparts an impulse, or changes the momentum of each of the colliding objects. But if the system of particles is isolated, we know that momentum is conserved. There are two different types of collision. Elastic collision is a collision in which there is no loss in kinetic energy. Both momentum and kinetic energy are conserved. And an elastic collision is a collision in which there is a loss of kinetic energy, but momentum is still conserved. An example of elastic collision would be if two cars were going at 10 miles per hour and they collide and bounce off, still going at 10 miles per hour. In the real world, that is not possible, but it would be an example of a perfect elastic collision. In the first video, you can see that it is elastic due to them bouncing off. But again, it is not perfect because the balls do not have the same initial and final velocity. But the second video was almost perfect inelastic collision with the help of some gum because the balls did not bounce off of each other.
Know how I feel. Why would you say that? Like, you put me in such an uncomfortable situation. Like, you know I'm not happy. You know I'm trying